Between these two intervals, the curve is passing through the x-axis. This is the absolute relative approximate error which we can find out after every iteration. I considered a equal to 0, b equal to 0.11. I obtained the root 0.0660. Hello everyone, it is Dr. Ravikumar YB. Today I will teach you about the method of false position. The method of false position, also called as regular falsi method. What is this regular falsi method stands for? Again, a regular falsi method is an iterative way of finding the roots of an equation. In my previous session, I was discussing about the Newton-Raphson method for a function f of x equal to x cube minus 0.165 x square minus this equation. That is the equation 0.165 x square plus 3.993 into 10 to the power of minus 4 was the equation given at the first problem of Newton-Raphson method. In today's class, we shall see as to how we can find out the roots of an equation using the regular falsi method or by the way of method of false position. Here, we will not find out the roots of an equation directly. Instead, we will find out the roots of an equation through indirect way of that. What is the meaning of indirect way of that? That means we are going to find out the roots of an equation through f of x, not through x directly. That is, as I have already informed you about the roots of an equation which can be found when the curve crosses the x-axis. That is, in this case, the curve is crossing the x-axis at this point of juncture. I'll call this as the roots of an equation lies at this point. Suppose if I find the values based upon this x and a and b are the two intervals. In this case, xl is called as left and this is called as upper bound, lower bound and upper bound, or in other words, I'll call this as A or this as B. In my conventions, I'm using A and B as the two intervals wherein A represents the lower bound, B represents the upper bound. Between these two intervals, the curve is passing through the x-axis. That means exactly at this point of juncture, the root lies. So I want to find out by the way of iterative method where exactly the root lies for an equation given by the questionnaire. Now, in this case, we are going to have this formula, that is xi plus 1. That is, xi plus 1 means if I substitute the value of this I equal to 0, it becomes x1 equal to x0 minus f of x0 into x0 minus x minus 1. Please keep this in your mind. We do not have a minus 1 here. If that is the case, what has to be done here? It has to be 1. 1 plus 1 is what? x2. x2 equal to x1 minus f of x1 into x1 minus x0 divided by f of x1 minus f of x0. That means we are going to find out the roots of an equation based upon the previous two iteration value. That means if I want to find out x2, I need to find out the value of this with x1 and x0. If I have the reference of these two previous values, I can find out the value of x2. Suppose if I want to find out the value of x3, I need to have the value of x2 and x1. If I want to find out the value of x4, I must have the value of x3 and x2. So this is how the method of false position works. If that is the case, this is the main formula for finding the roots of an equation using the method of false position. You can remember it very easily. That is, if A is one of the terms mentioned here, one of the intervals, and B is another interval, A into f of B minus B into f of A divided by f of B minus f of A. That is the formula we are using in method of false position. If you remember the formula of Newton-Raphson method, wherein you are going to have x plus 1 is equal to xi plus 1 is equal to xi minus f of xi divided by f dash of xi. That was the formula we were using in Newton-Raphson method. In case of regular falsy method, we will use xi plus 1 is equal to, or xi is equal to a into f of b minus b into f of a divided by f of b minus f of a. That is the formula we use to find out the roots of an equation in the present iteration, that is xi. That is, when the value of I is equal to 0, it is a into f of b minus b into f of a divided by f of b minus f of a, provided the condition for that is f of a into f of b must always be less than 0. If it is less than 0, what has to be the value of a and b for the next iteration, which you have already learnt in the previous class, that is in the bisection method. What is the formula we use in case of bisection method? That is midpoint value c is equal to a plus b by 2. That is the formula we apply. Then we apply the value of c into the function f of x to find out the value of f of c. Now, similarly, we are going to have the values of those a and b here, where a is the initial value, one of the interval or initial value, and b is another initial value. A and b are called as the intervals. A and b are called the intervals. Between a and b, the root lies, that is at this point of juncture. So, we must have the values of a as well as f of a, b as well as f of b. If that is the case, what is the value of a then? Let us try to work out on the equations of that. If I substitute the value of a is equal to 0, what is f of 0? If I substitute the value of b is equal to some value, and what is f of b? If I have these values, I can find out the values of x0. Then, similarly, in the equation, let us consider one of the example problem to solve in the regular falsy method. This is the formula I discussed now based upon this condition. This is the absolute relative approximate error which we can find out after every iteration. That is xm new, that means m is equal to 1. xm old, that means the previous iteration value divided by present iteration value into 100 gives us the absolute relative approximate error. Then this is the given equation. What is that equation given here? F of x equal to x cube minus 0.165 x square plus 3.993 into 10 to the power of minus 4. This is the equation given to us. In this equation, we are going to substitute the value of a is equal to 0. That is, when the value of a is equal to 0, what is f of a? That means f of 0. 0 cube minus 0.165 into 0 square plus 3.993 into 10 to the power of minus 4. This leads to the term of this. This leads to the value which is equal to 3.993 into 10 to the power of minus 4. Now, if I substitute the value of b, which is equal to 0.11, if I substitute the value of b is equal to 0.11, Then what is f of b? That is f of 0.11, which is equal to 0.11 whole cube minus 0.165 into 0.11 whole square plus 3.993 into 10 to the power of minus 4, which is equal to, that is equal to 2.662 into 10 to the power of minus 4. Now we have got the two values a and b as well as f of a and f of b. With this, I can say that whether f of a and f of b is less than 0. Right? See here, what is f of 0? F of 0 is 3.993 into 10 to the power of minus 4. This one. What is f of 0.11? Which is 2.662 into 10 to the power of minus 4. If I multiply these two terms, that is 3.993 into 10 to the power of minus 4 multiplied with 2.662 into 10 to the power of minus 4, that leads to the value which is, it is not 2 point, it is minus 2 point. Please be careful here. It is minus 2 point. Plus into minus, always it leads to plus sign, into negative sign always leads to a negative sign. So it is minus value 3 2s are 6. Minus 6 point something you will get, that is into 10 to the power of minus 8. So which is less than 0. If it is less than 0, what has to be the values of a and b in the next iteration? Before moving on to that, let us consider the formula, that is xi, where xi is equal to a into f of b minus b into f of a divided by f of b minus f of a. We have to apply this function, that is the values of that a and f of b, b and f of a, f of b, f of a into this formula. That is, if that is the case, what is the value of a? 0. 0 into, what is f of b? Minus 2.662 into 10 to the power of minus 4 minus b. What is the value of b? 0.11 into, what is f of a? That is f of a is 3.993 into 10 to the power of minus 4 divided by f of b minus f of a. What is f of b? This one. Minus 2.662 into 10 to the power of minus 4 minus f of a, that is 3.993 into 10 to the power of minus 4. So obviously this term leads to 0. This term leads to the value which is this one. This entire term leads to 0. This entire term leads to 0, that is a into f of b minus b into f of a. This leads to 0.11. You shall see here. 0.11 into 3.993 into 10 to the power of minus 4. 0.11 into 3.993 into 10 to the power of minus 4 divided by 3.993 into 10 to the power of minus 4. This minus into minus, this leads to positive value. That is this value. It is in the denominator, you will find out the value of this. So totally this turns out to be 0.0660. That is, in this case, 0.113, 0.11. Let me solve it here. 3.993 into 0.11, that is leads to this leads to, after two decimal places, 1 2 3 4 5, it leads to 0.5 43923, that is 0.43923 into 10 to the power of minus 4. In the denominator, we have this value, that is 3.993 into 10 to the power of minus 4 minus this. What is the value of that? Let us calculate it here. 3.993, in this case 2.662. We have one term borrow here, one term borrow here. This becomes this, one term borrow here, borrow here. This becomes 9. We have 6 minus 2.669 into 10 to the power of, you shall see it here, yes, into 10 to the power of minus 4. This 4 gets cancelled. This becomes equal to, if you further simplify these two values, numerator and denominator, you will get 0.0660. This is called as my x1. This is in the first iteration. In the first iteration, you are getting the value which is 0.0660 in the value. X1 is equal to 0.0660 is the value which you have obtained in the first iteration. In the next iteration, let us see. Before moving on to the next iteration, we have to find out the absolute relative approximate error. What is that? In case of this, we have found the value of this x1 here. Now, let us see what is f of x1. F of x1 means f of 0.0660 is equal to 0.0660 whole cube minus 0.165 into 0.0660 whole square plus 3.993 into 10 to the power of minus 4. This leads to the value minus 3.1944 into 10 to the power of minus 5. Now, you need to observe that this is a negative value, that is f of x1. Now, if you multiply f of a with f of x1, earlier we had been multiplying the value f of a with f of b. If it is less than 0, what is that we were supposed to do? In this case, it is less than 0, which is positive. One of the value is positive and the other one is negative. What is f of a? F of a is this, 0. If I substitute the value 0 into this equation, what happens to this? 3.993, which is positive. See here, which is 3.993 into 10 to the power of minus 4, which is a positive value, into what is f of b? This minus 3.1994 into 10 to the power of minus 5, which is a negative. That is, positive into negative always leads to a negative value. That is, if it is f of a into, that is f of a into f of x1 is less than 0. If it is less than 0, what has to be done in the next iteration? See here. Observe here carefully. If it is positive, we have to assign the value of a equal to 0 as it is, and b changes from 0.11 to 0.0660. Now we have the value a is equal to 0, b is equal to 0.0660. This is my new value for the next iteration, a and b. See here, in the first iteration, I considered a is equal to 0 and b is equal to 0.11 in the first iteration. In the next iteration, I am considering A is equal to 0 and B is equal to 0.0660. That is, A is equal to 0 and B equal to 0.0660 for the next iteration. How did I found the value of B is equal to 0.660? From the value x1, which is the value which we have obtained in the previous iteration. That is, this is also called as an x1 value. I am assigning it to x1 value to B if it is negative. If it is positive, this would have become the value of this. That is, 0.0660 would have been the value of A and B would have been the value of 0.11. In this case, it is negative. That is, f of A into f of x1 is negative, which is less than 0. I am assigning the value of x1 to this B. That is, B is equal to 0.0660. A equal to 0. Now, in the next iteration, I will apply these values into the formula, that is f of x2. That is, x2 is equal to A into f of B minus B into f of A divided by f of B minus f of A. In this case, A is equal to 0 into B into f of B. What is f of B? See here, B is equal to 0.0660, right? What is f of B? Let us find out the value of f of 0.0660, which is equal to 0.0660 whole cube x cube minus 0.165 into x square means 0.0660 whole square plus 3.993 into 10 to the power of minus 4. If I substitute these values and it turns out to be the value which is equal to this one, 3.993 into 10 to the power of minus 4 minus this one, minus 3.1944 into 10 to the power of minus 5. Now, minus this one, minus B into f of A. What is the value of B in the previous iteration you have seen? It is 0.0660. So, 0.0660 into f of A. What is f of A? That is this one. When you substituted the value of A equal to 0, you obtained this value, f of 0, 3.993 into 10 to the power of minus 4. So, we have this term, 3.993 into 10 to the power of minus 4. Whole thing divided by f of B minus f of A. What is f of B? 3.1944 into 10 to the power of minus 5 minus 3.993 into 10 to the power of minus 4. So, if you further simplify this turns out to be a 0 value. If you solve this, you will get the value which is equal to that. So, let us solve this value. 0.0660 into 3.993, which leads to 0 3s are 0. Which turns out to be 0.00105380. How many, after how many decibels? 1, 2, 3, 4, 1, 2, 3. 2, 3, 4, 1, 2, 3. So we have the value which is equal to 0.01053880 divided by this term, If you solve this equation, you will get around the term which is, let us solve this as well. That is 3.1944, 3.9930, that is 410 minus 1.2014. Anyways, you have the negative sign here, negative sign gets cancelled, then immediately it turns out to be the value 0.0611. This is the value of x2, that is the value of x2, that is the value of x2 equal to 0.0611. Now you have found the value of x2 equal to 0.0611. With this, what has to be done? Since it is f of a into f of b must always be less than 0. We shall see what is the value of f of a into f of b. What is this? x2 equal to this value, which is negative, positive. Now, f of a into f of b must always be less than 0. This is the condition. In this case, what is f of a? F of 0 into f of b. What is the value of f of b? That is 0.0611. That leads to 3.993 into 10 to the power of minus 4 into this one, 0.0611. If I substitute this 0.0611 into this original equation, f of 0.0611 equal to 0.0611 whole cube minus 0.165 into 0.0611 whole square plus 3.993 into 10 to the power of minus 4, which is positive value, since we have a positive value. So this is again a positive value. That turns out to be some positive value. Plus into plus always leads to some positive value. If it is positive greater than 0, then what has to be the next value of a and b for the next iteration? For the next iteration, a is equal to, see here, observe this. This is the value of x2 in the current iteration. That is x2 equal to 0.0611. In the previous iteration, that is in x1, in this case, x1 was 0.0660. Then here I had got the value which was negative. So what did I do? x1 was assigned to b. If it is positive, it has to be assigned to a. Then if in this case, what has to be the value of a and b? A is equal to 0.0611. What has to be the value of b? 0.060. This has to be the values of a and b for the third iteration. See here, a is equal to 0.0611, b is equal to 0.0660. In the third iteration, in the second iteration, what is the value I got? Second iteration. In the first iteration, I have got x equal to 0.0660. x2 is equal to, in the second iteration, 0.0611. In the third iteration, what happens? Let us see to it. This is the value I am considering for the third iteration. Now in the third iteration, I have obtained the first and second iteration value. Absolute relative approximate error can be found using this 0.0611 minus 0.0660 divided by 0.0611. Absolute value of that into 100. That turns out to be equal to 8% of error. Now in the third iteration, I have to consider these values A and B. If that is the case, what is the value of A? A is equal to 0.0611, B is equal to 0.0660. The same thing was considered, right? Now, in this case, what is the value? Let me apply these values into the equation. Before that, I want to find out what is f of A and f of B. That is, f of 0.0611 is equal to 0.0611 whole cube minus 0.165 into 0.0611 whole square plus 3.993 into 10 to the power of minus 4. That turns out to be the value which is equal to this value. That is this value. Let us solve that value, 0.0611 whole cube. That leads to by the value, the positive. Then similarly, f of this value 0.0660 is equal to 0.0660 whole cube minus 0.165 into 0.0660 whole square plus 3.993 into 10 to the power of minus 4. That also leads to some positive value. That is, we shall calculate it. This is the value we have obtained from this. That is 1.132 into 10 to the power of minus 5. What is the value we have obtained for this? Minus 3.1944 into 10 to the power of minus 5. Now, if I apply these values into that equation, x3 is equal to A into f of B minus B into f of A divided by f of B minus f of A. If I apply these, substitute these values into this equation, what is the value I get? Let me show you that. Here, A, what is the value of A? That is 0.0611. 0.0611. A into f of B. This is 1.132 into 10 to the power of minus 5, and this is equal to 3 minus 3.1944 into 10 to the power of minus 5. Now if I substitute all these values into this equation, that is A. What is A? 0.0611. B. What is f of B? That is minus 3.1944. Minus 3.1944 into 10 to the power of minus 5 minus B. What is the value of B? Value of B is 0.0660 into f of A. What is f of A? 1.132 into 10 to the power of minus 5 divided by f of B minus f of A. That turns out to be the value 0.0624. This is the value I have obtained. That is, x3 is equal to 0.0624. This is the value I have found in third iteration. Let me sum up all these values. 0.0624 is the value I have found in the third iteration. Next, if you look at this, this is the function I was given, and in the initially I considered A equal to 0, B equal to 0.11. I obtained the root 0.0660, and in this case again A equal to 0, B is equal to this value. Since it was negative, it was a negative value, I used this to this. Now x1 is the value, x2 is the value I obtained here, that is x2, this is x1. Then epsilon here, it was 8% around. Then it is again a negative value, 10 to the power of minus 5. Okay, it is positive, it is positive, it is positive. What has to be done? This must be assigned to this, and this remains as it is. Then for this I have obtained x3. What is the percentage of error I got? 0.2 something I got percent. Then again we have got a negative value here, again a negative sign here. If it is negative sign, what has to be done? The same thing is kept as it is, and this must be the new value. Now I have got x4. This is the 0.02% of error I found. This is again a negative value. If this is the case, this becomes my new roots of this equation. Where is the roots of this equation? This is the roots of this equation. What is the roots of this equation? 0. This is equal to 0.06323. The root lies at this point of this juncture, at this point of juncture, that is 0.06323. This is how the method of false position works. If you have any questions or any doubts to be cleared, please clarify it in the live session. And you shall also see that one more thing you need to be very careful when you assign these values into it. When the value of this is negative, you have to consider the value of x1 into b. When the value of this is positive, this root of this must be assigned to a. So in the previous case, when I was solving the bisection method, if it was negative, what was the value of a? If it was negative, what was the value of b? That thing was explained in bisection method. Similarly, in case of regular falsy method, if the root, that is this f of xi turns out to be a negative value, the root becomes, that is x1, first iteration becomes the value of b. If it is positive, that x2 becomes, in the second iteration, it becomes the value of a. So this process is repeated until there is an error, that is selective error, that is this if epsilon a, absolute relative approximate error, is less than selective error, specified error. If when the value of this is less than this, when the value of this is less than this specified error, we stop iterating over that. That is, in the earlier case, I was getting around 8% was the error. In the next iteration, I got 2.05%, which is again greater than 0%. So then again in the fourth iteration, I got 0.02%, which is 0.02%, which is less than 0.5%. So I stopped executing there, and this is the root of the equation. So I have found the root of the equation at fourth iteration, that is 0.06323. Similarly, if the same equations would have been solved using that bisection method, we would have got more number of iterations. If we had the bisection method, we would have got 8 to 10 iterations to solve this equation and to find the roots of an equation. In this case, we have been able to use only 4 iterations to find the root of an equation. Even in case of Newton-Raphson method, for the same equation, we considered only 3 iterations to find out the roots of an equation, which you have seen in the previous class. So again, the bisection method is a successive approximation method that takes more time to find out the roots of an equation in comparison with Newton-Raphson and regular falsy method. If you have any questions or doubts, please clarify those questions and doubts in the live session, which would be conducted from 9th of this month. Thank you all. Thank you.